Hello everyone, this is Dr. Roji Shrestha, and I had presented my poster in the first ODOAN PG convention on the topic in-house aligner, scan and smile. So introducing increase in the aesthetic need of patients for the orthodontic treatment has led to the development of clear aligner therapy. Traditionally, orthodontists they contract with the outside services to provide clear aligners. However, the outsourcing to a provider has drawbacks such as prolonged production delivery time and also requires substantial amount of fees. So to overcome these challenges, orthodontists have adopted the in-house aligner or the in-office aligner systems, where all the aspects of fabrication from digital treatment planning to orthodontic care delivery are handled within the office itself. Now, there are various steps that needs to be followed during the fabrication of in-house aligners. First is the data acquisition, where the maxillary and mandibular digital working models and recording of the patient's occlusion can be done directly on patient with the help of the intraoral scanners or by digitizing the analog impressions or plaster models with the desktop scanners. Next is the aligner setup or the digital treatment planning, for which numerous softwares are available, and most of these software have a typical workflow. First, beginning with the orientation of the model according to the occlusal and sagittal plane. Next is the segmentation, for which the software asks the operator to define the medial and distal surface of the tooth or the central point on the occlusal surface of the tooth, and in this way the software separates each tooth from the arch. So after the segmentation, we can now go for the virtual setup. Here all or each individual tooth can be moved according to the treatment planning. Now when the virtual setup is complete, model is then prepared by hollowing it out, leveling, and also adding the printing platform, and finally these models they are then exported for the three-dimensional printing. So these 3D printing can be done with the help of stereolithography or the fused deposition modeling. Among these two, the stereolithography or SLA is most widely used for its precision and a well-finished surface. And during the printing in SLA, an object is formed by selectively curing a resin layer by layer using a UV light beam. So after the model is being printed, these model needs to be post-processed by cleaning it in the alcohol, and also requires a post-print curing process. So after the model is ready, now aligner thermoforming is the next step that is done using the vacuum or pressure forming machines, where the pressure forming is recommended because of its increased fit and adaptation to the resin model. Now final step is the trimming and polishing, which can also be done manually, or we can also have the automatic trimming machines, followed by packaging and delivering of aligner to the patients. Now these are all the steps in the fabrication of in-house indirectly printed aligners. Now in case of the directly printed aligners, same procedure can be followed till the setup stage, and after which the operator must design the aligner at the initial malocclusion model, and that will be used by the software to create all the rest of the aligners. Now these directly printed aligners, they are more precise, they have increased load resistance and have lower deformation as compared to the indirectly printed aligners. Now the overall advantage of the in-house aligners is that as compared to the commercial aligner laboratories, it enables complete control over the treatment plan by an orthodontist. It helps to achieve faster production of aligners and also eliminates the outside lab fees, so it is also economical. And so thus concluding my poster, in-house aligners, they are the best option for faster and economical services, and it just requires the flexibility and an openness to learn new workflows that can carry our practice forward.